Hello, welcome to one and all. Welcome to the video lecture series on 886 microprocessor. So generally, microprocessor is nothing but a CPU on a chip. So here the basic processor, the first successful processor is 8085 microprocessor. Now we are going to discuss about this 8085 microprocessor. Okay. So this is the what we'll call architecture of our 8085 microprocessor. Okay. So a microprocessor is nothing but a CPU on a chip. Here we are having only central processing unit. The rest of the components like memory, A to D converters, D to A converters, these all we need to uh, interface externally. Okay. So coming to this 8085 microcontroller, this is very important microcontroller in many aspects because this is the Intel has started developing a microprocessor since from 1971. First they developed 4004, which is a failed version, 8008, 8080. These all are failed versions. The first successful version is 8085 microprocessor. It has somewhat little bit real-time applications. Okay, so coming to this architecture of 8085, basically it is a 8-bit microprocessor. What is meant by 8-bit microprocessor means generally its size depends based on the number of data lines. Okay, here we are having 8 data lines. Here you can see AD0 to AD7. That means we will call multiplex address data lines. Okay, so we are having 8 data lines. That means we can each data line can transfer 1 bit of a data at a time. That means as we are having 8 data lines, it can transfer 8 bits of data at a time. So it is called 8-bit microprocessor. Okay. Next, it is having 15 address lines that among them the lower order 8 address lines, AD0 to AD7. That means these A0 to A7 are multiplexed with data lines. That means the same line. That means the same bus can be used as an address bus as well as a data bus. That means the lower 8 bits of address line are multiplexed with the lower the bits of a data line. Next, the higher order address lines A8 up to A15 can be seen here. Okay. Here, what is meant by bus? Bus is nothing but a group of bytes. Next, here also the registers are generally we are having 8 registers. So these all are 8-bit registers. Among them, so if you can observe here, B and C, they are written as two separate registers. These two are the general purpose registers. D, E, H, L. These are the 6 general purpose registers that are present in 8085 microcontroller. Here you can use only the B register, means it is an 8-bit register, or you can use this BC together and use it as a single 16-bit register. Similarly with the D, if you use only D, then it will be 8-bit register. We use only E, then it will be 8 register. But DE combined means you can use it as a 16-bit register. Okay. Next, we are having a program counter. All these things are present here. So we are having accumulator, a arithmetical and logical unit, a serial IO, instruction register, timing and control register. Here you can see a lot of pins in the timing and control register, and X1, S2 are the crystal oscillator pins. That's what we are going to discuss in the next slide. Okay. So these are the features of 8085 microprocessor. It is generally an 8-bit microprocessor. That means it is having as why it is called 8-bit microprocessor means as I have told you previously that it consists of 8 data lines, so it can transfer 8-bit of data at a time, and it is having 16 address buses. Among them 8 lower order address lines buses lines are multiplexed with the data lines. Next, we are having see here you can observe it is having 8-bit data bus. So 8-bit data bus means we are having 8 data lines, so it can transfer 8-bit of a data at a time. The pin diagram consists of 40 pin. This 8085 works under 5 words DC supply, and X1, X2 are the pins that can be seen in the diagram. So it requires a clock speed of 3 megahertz. This is the clock frequency of this 8085 micro processor. Next, it consists of 6 registers that what I have discussed already, B, C, D, E, H, L. These 6 registers are general purpose registers. Among them, we are having program counter, accumulator, and a stack register also. Coming to the instruction set, the instruction set it supports 74 basic instructions. Okay, so the instruction set size is 74 instructions and with 246 opcodes. And what is mean by an interrupt? Interrupt is nothing but a breakage to the normal flow of a program. Generally, program is nothing but set of instructions. Due to any reason, there is a breakage to the normal flow of a program, then it will be called as a interrupt. So interrupts here are classified into, there are 5 types of hardware interrupts. Those are trap, reset 7.5, 6.5, 5.5, and INTR. Next, here we are having, it supports serial communication. So there are 2 pins called SID and SOD, serial input data pin and serial output data pin. Next, it is having a built-in clock generator. It supports direct memory access, and general, this is the main important. It consists of 5 flag bits like sign flag, zero flag, parity flag, carry flag, auxiliary carry flag. So sign flag will be enabled when the answer is 0. That means if you subtract 2 same numbers, or if you go on decreasing a value, then if you get 0, then sign flag will be, so then zero flag will be enabled. Sign flag will be enabled when you get answer negative. That means if you subtract a big number from a smaller number, for example 50 minus 70, you get minus 20. Whenever you get an answer as negative, then sign flag will be enabled. Zero flag, whenever the answer is 0, okay, then the zero flag will be enabled. Auxiliary carry, from lower nibble to higher nibble. That means from, if you start the bit from 0, whenever a carry generated from third bit to fourth bit, then it will be called as auxiliary carry. Parity bit, that means if you will get a value in hexadecimal number. If you convert that value into binary number, and if you count the total number of ones in that given answer, if the number of ones in a binary value what you have obtained is even, that means if you get even number of ones in the result, then automatically parity flag will be enabled. Okay, if we get odd number of ones, then the parity flag will be 0. Okay, next, carry flag. The carry flag will be enabled when we get a carry while performing addition operation or multiplication operation, or this same carry flag will be enabled when we get a borrow. That means when we subtract a small number, a big number from a small number, automatically we need to get some borrow. That time also the carry flag will be enabled. Okay, so these are the various types of things that are present here. And these are the limitations of our 8085 microcontroller. So basically its clock frequency is very less. Next, it is only an 8-bit microcontroller. That means it can process only 8 bits of data at a time. So it is almost a slow one. Next, it don't have any proper instruction set. There are some instructions, little bit of instructions, and those are also not a proper instruction set. That means I cannot perform signed operations in the by using this one. Signed multiplications or signed division. They don't give a proper answer. What is this 8085 micro processor? And the main drawback is we don't have any pipelining mechanism. Pipelining means subsequently or simultaneously, program is nothing but set of instructions. Pipelining means if one instruction is under execution, the next instruction is going to perform decoding, whereas the third instruction will be under fetching stage. That means it is a 3-stage pipelining. One instruction will be fetched, another instruction will be decoded, and the starting instruction will be executed. That means once a first instruction is in execution, the second instruction will be in decoding stage, and third instruction will be in fetching stage. This is a 3-stage pipelining. That means at a time 3 instructions can be executed parallelly. So that means they will be operated parallelly. If we are having 5-stage pipelining, 5 instructions will be simultaneously in progress. This will increase the speed of operation, but that kind of phenomena is not present in 8085. So due to all these limitations, lack of proper instruction set, no pipelining. Next, it is only 8-bit microprocessor, so it can its processing speed is very less. It will take a lot of time for execution. All are the drawbacks of 8085 microprocessor. And this is the pin diagram of 8085 microprocessor. So we can see that AD0 to AD7 multiplexed address data lines you can see here. Okay. Next, higher order address lines A8 to A15 can be seen here. Next, X1, X2, these are the crystal oscillator pins. In between these 2 pins, we will connect this crystal oscillator. So by using the crystal oscillator, we are going to generate a signal of 3 MHz frequency. Next, this is serial input data pin and serial output data pin. So these pins are used for serial data transmission. And as we have discussed that there are hardware interrupts. These are the hardware interrupt pins. INTR, see these RST 5.5, 6.5, 7.5 trap. Next, these two are interrupt request and interrupt acknowledgement pins. If you are requesting an interrupt, that can be given by using INTR, and the response will be given by INTA pin. Next, we are having two operations, read bar and write bar. Read bar is nothing but it is transfer. Here we can see that IO by M bar. See these read bar and write bar operations and ALE and IO by M bar. These all are used together. Okay. So first here you can see IO is a logic high and M is logic low. So if I give this pin, if I apply logic 0 to this pin, then M bar will be enabled, and that means memory. Okay, and if I give RD0 and WR bar 1, among these two, read will be highlighted. That means here 0 means memory. Here among these two, I should not give 0 at a time to all these two, because we cannot perform read and write operations simultaneously. So when I give here also 0, then it will become memory read operation. Okay, when I give read bar as a when I give read bar as 1 and write bar as 0, then automatically it will become write operation. And if I give IO by M bar 1, then it will become IO write. Like this, we can use ALE means address latch enable. This is used because we are having multiplexed address data lines. When it is 1, that indicates the address is being transmitting through our AD0 to AD7 lines. If it is 0, the data is going to be transmitting between AD0 to AD7 multiplexed address data lines. Okay. Hold acknowledgement. So hold is nothing but a request to a direct memory access. So if any device can request to a DMA direct memory access, then it is called hold. Okay. So whenever it receives a request, it immediately the process request and receives and request, it immediately sends to a reply to that particular device. That means, okay, after executing the present task, I am going to execute a task next. That is called hold acknowledgement. So these are the various pins that are present in our 8085 pin diagram. Totally 40 pins, 8 multiplexed address data lines, 8 address line, another 8 address lines. Next, 2 crystal oscillator pins, interrupt pins. Next, hold acknowledgement. VCC is nothing but 40 pin. VCC is nothing but supply. It requires 5 volts DC supply. So that is the pin we want. VSS is nothing but ground pin. Okay. So this is about overlook or outlook of an 8085. In the next classes, we can discuss in depth. Okay. Thank you.